Okay, so here is section 8.5 in a nutshell. So we're going to move pretty quickly. You may have to use the pause button a good bit. I'm going to plow right on through, and if I'm going too fast, then pause, rewind, listen again, and enter things into your calculator when we get to the calculator section to make sure that you're understanding what's going on. For this first half of the lesson, you'll need to make sure that your unit circle is out, because I'm going to refer to it pretty frequently on this first part. Excuse me. So this is a two-step process, and we've already done this earlier in chapter 8, so every single thing in 8.5 is a review. So the two-step process is, number 1, figure out where it is. Number 2, figure out the coordinate. After you've done those 2 steps, then you can figure out what the sine or the cosine is. Totally ignore the trig until you have found out where it is and what the coordinate is. So that's what we're going to do. So for number 2, where is 5 pi over 3? 5 pi over 3 is this spoke down here. We've got a short and a long, so that's going to be at 1/2 negative root 3 over 2. Cosine value is my x value, so that's going to be 1/2. Number 6. Where is 11 pi over 6? Well, it's the very last spoke in the 4th quadrant. Coordinate there, we've got a long and we have a down short. So that's going to be root 3 over 2, negative 1/2. Cosecant is not something that's memorized, but it is the reciprocal partner of sine. So if you know that sine is your y value, all you have to do is take your y value, get the reciprocal, and you're done. So the reciprocal of negative 1/2 is negative 2. Number 10, the problem with 17/3, 17 pi over 3, is that's not on our unit circle, and so we have to go through a little bit of thinking to figure out where this is. 17/3 is the same thing in 3rd grade math as 5 2/3. Literally, this is 5 whole entire pies and 2 more thirds of a pie. 5 pi, if you just simply count, then what you'll have is, here is 0, here's 1 pi, go back around, 2 pi, 3 pi, 4 pi, and then 5 pi is coterminal to the original pi that we have memorized. So 5 pi, and then I need to add to that 2 pi over 3. So that's going to be, here would be, if I'm starting at 5 pi, here would be 1 pi over 3, here would be an extra 2 pi over 3. So this is the spot that I want to focus on then. And I think, yeah, this is going to be 1/2. Oops. Try that again. This is going to be a 1/2 and a down root 3 over 2. So negative root 3 over 2. So then all I need to do is now I can focus on my tangent value, which is my y value divided by my x value. So my, sorry about that, I can't find it. My y value divided by my x value, negative root 3 over 2 divided by 1/2, invert and multiply, and then I get a negative root 3. All right, so down on the next line then. Negative 4 pi over 3. Well, I know that a positive 4 pi over 3 goes all the way around the circle and stops at the last spoke in quadrant 3. So I need to go the exact same distance and the exact same amount, just in the negative direction. So I'm going to go all the way around the circle and the last spoke then in that 3rd quadrant. So this is coterminal to 2 pi over 3. My coordinate is going to be negative 1/2 root 3 over 2. Secant is tied to cosine. It's the reciprocal partner of cosine. Cosine is the x value. So if cosine is negative 1/2, secant is going to be the reciprocal of that, which is negative 2. 13 pi over 3. This is another one of those places that I don't really know what it is. So I think of this, 13/3 is the same thing as 4 1/3. So 4 1/3 is going to be 4 whole pies plus another third of a pie. And so 4 whole pies is going to be over here at my original starting position, and all I need to do is add 1/3 of a pi to that. So I'm just going up to pi over 3. So the coordinate there, 1/2 root 3 over 2. I want the cotangent. If tangent is y over x, then cotangent is going to be x over y. So my x value 1/2 over my y value root 3 over 2. Invert and multiply. Cancel your 2's. Multiply what's left over and rationalize the denominator. Root 3 over 3 then is the cotangent value. So here we have cosine of 7 pi over 4. 7 pi over 4 is smack dab in the middle of the 4th quadrant. So it's going to be root 2 over 2, root 2 over 2, but my y value is going down, so it's negative. Cosine is going to be my x value, so it's going to be root 2 over 2. And then my last example of these, 5 pi over 4 is going to occur smack dab in the middle of the 3rd quadrant. My sine value is my y value, so you have negative root 2 over 2 for the sine of 5 pi over 4. The next few questions are exactly the same, only instead of asking one single one, I'm asking about all 6. I'm only going to pay attention to the ones that are highlighted, so if it's not highlighted, I'm not going to do that here on the video. I did not do it in class either. So once again, first of all, figure out where it is. 3 pi over 4 is smack dab in the middle of the 2nd quadrant. Secondly, get your coordinate, so that's negative root 2 over 2, root 2 over 2. And then go find your value. So cosine is going to be my x value, negative root 2 over 2. In order to get my secant, all I have to do is flip my sine value over. So there's the work on that. 2 over root 2. Rationalize the denominator, cancel what you don't need, and you have a negative root 2 left over. Tangent is y value over x value. So since the y value and the x value are identical, I get a 1. Just don't forget about the negative. The reciprocal of tangent is cotangent, so that's also negative 1. Next, where is negative pi? Well, negative pi is the same place that positive pi is. So the coordinate there is negative 1, 0. My sine value is my y value, that's 0. My cosecant, if you flip 0 over, remember that this is actually my y value over my radius, which is 1. So 0 over 1 flipped over is going to be undefined. The cosine value is the x value, so that's going to be negative 1. And tangent, y value over x value, 0 over negative 1 is going to be 0. For number 20, negative 5 pi over 6. So once again, think about what you have to do to get to the positive version. You got to go through the whole 1st quadrant and 2 more spokes to get to the positive version. So I want to do the same thing in the opposite direction. So go through a whole quadrant and then 2 more spokes. It's going to be coterminal with 7 pi over 6. So the coordinate there, negative root 3 and negative 1/2. Sine value is going to be my y value, which is negative 1/2. Cosecant is the reciprocal of that, so it's going to be negative 2. All right, now it's time to pull out your calculator and make sure that you're typing this into your calculator. You'll need to pause because I'm going to keep on moving. Pause, type it into your calculator, make sure you get the same thing I do. The first 3 are really easy. You simply type in exactly what you see. So for number 30, sine of 0.8203, I type that into my calculator and I'm going to get 0.7314. If you did not get that number, it's very possible that you're working in degrees. Notice I have no degree symbols on any of my angles, so I'm working in radians. Your mode needs to be in radian mode. Going to number 32, if you type in the cosine of negative 5.2825, you're going to come out with 0.5397. And for number 34, if you type in the tangent of 6.4752, you're going to get 0.1944. The next 3 are not as easy because you don't have buttons for cosecant, secant, or cotangent, so you have to do a little bit of extra work on this. And the main thing is you've got to remember your definitions. So I know that cosecant, I'm going to write this here up at the top, cosecant of theta by definition is equal to 1 over the sine of theta. So when I look at number 36, I have cosecant of a theta. My theta is 1.3875. So the first thing I'm going to do is rewrite it by definition as a sine. So that's the same thing as 1 divided by sine of 1.3875. That's what I'm going to type into my calculator, and I'll get 1.0170 when I round properly. Same thing with number 38. Change your secant, first of all, into a cosine by definition. So it's 1 divided by cosine of that -8 number. Type that into your calculator, and you should get negative 2.1291. For number 40, rewrite cotangent as tangent by definition. So you have 1 divided by tangent of that 3 number. Type that into your calculator properly, and you're going to get 1.1848. Number 42 is also a question that we have done before. So remember that sine is going to be my y value over my r value. In this case, my r value is a radius of 1, so this one's pretty easy. But if it were something like the coordinate -3, 4, my r value is no longer 1. I would need to do the Pythagorean theorem to find out what my r value is. Go back to sections 8.1 and 8.2 to be able to find questions exactly like that. So here, going back to number 42 then, my sine value is my y value divided by 1, so that's going to be 8 over 17. Cosine is my x value divided by 1, so it's going to be negative 15 over 17. Tangent is y value over x value, so 8/17 over negative 15/17. Invert and multiply, cancel your 17s, and you have left a negative 8 over 15. Cotangent, flip it over, and you're good. Back to some calculator questions. Remember the phrase that says inverses find angles. So since I need to find angle S here, and notice that my angle is in radians, so make sure that your calculator is in radian mode. Find my angles, then I'm going to take number 56 and I'm going to rewrite it first using inverses. So I'm going to be typing in cosine inverse of that big old long decimal in radian mode, and I'll come out with an angle of 0.6718. Since my restriction is only the first quadrant, I don't need to come up with a plan. Earlier in this chapter, I came up with a plan and found all of the places where this was true, but I'm only working in first quadrant, so this 0.6718, that is an angle in first quadrant. For number 60, I do not have a cosecant inverse button. I don't have a cosecant button even. So I have to go about this a little differently. So the very first thing you have to do is make sure that you rewrite it as a sine. So since cosecant equals some ugly number, sine has to equal the reciprocal. Now I can use inverses, so I'm going to rewrite this as sine inverse of my fraction. This is what I'm going to type into the calculator. When I type it into the calculator, I should get 1.3631. For number 58 then, the last question. Once again, you don't have a cotangent button, you don't have a cotangent inverse button, so the very first thing you have to do is rewrite it as a tangent. So if cotangent equals 0.29, blah, 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 then tangent has to equal the reciprocal of that. So that's 1 over 0.29, blah, blah, blah. Now that it's written as a tangent, I can use tangent inverse. I'm going to plug this into my calculator, and I should get 1.2798. And that's all for section 8.5. So the test comes after this. And coming up, you have 2 videos in section 8.6, and after the test, we will be graphing using section 8.6 and 8.7.